Quadratic functions. A quadratic function has the form y equals ax squared plus bx plus c, where a is not equal to 0. We're going to look at the parent function, which is y equals x squared, and it looks like this graph. Notice the key values you need to know: 0, 0, 1, 1, 2, 4, 3, 9, negative 1, 1, negative 2, 4, and negative 3, 9. Please try to memorize this. The shape of a quadratic function graph is called a parabola, which is another word for U-shape. Parabola is one of the conic section graphs. There are many other conic section graphs, but the first one is the parabola, and a parabola is produced by cutting the cone with a plane parallel to the slant height. So here's the slant side of the cone, and the plane is parallel to it, and that forms a parabola. Important terminology you need to know about this unit. First, let's look at our x-intercepts. These are the points in which the graph intercepts the x-axis. Another word for x-intercepts is roots or solutions. Also, zeros can be another word for x-intercepts. On the graph, graphically, they're called x-intercepts. The y-intercept is the point in which the parabola crosses the y-axis. There's always only one y-intercept. You find the y-intercept by setting x equal to 0. You find the x-intercept by setting y equal to 0. Next, we have the vertex. The vertex is the minimum or maximum point of the graph. A vertex can be found by taking opposite of b over 2a, plugging that value into our function, and getting our y value. If our graph is concave up, as in this example of the graph looks, our vertex will be the minimum value of the function. On the other hand, if the graph is concave down, in that case, the vertex is the maximum value. Next, an imaginary line that goes through the center of the parabola that has the same x value as the vertex is called the axis of symmetry. Remember, always write the x symmetry as an equation. X equals the negative b over 2a. This divides the parabola in half. It makes it a mirror image on each side. I've been using the word parabola. Now remember, parabola is just the fancy word that represents the graph of a quadratic equation. Equations in standard form, the a, or the term from the x squared term, tells us a lot. If a is positive, the graph is concave up, and it'll be shaped like a U facing up. If a is less than 0, the graph will be concave down. If a is a number between negative 1 and 1, but not 0, then you have a wider graph than the parent graph. If a is greater, the absolute value of a is greater than 1, you have a narrow graph. Match the following equations to the correct graph. So let's start with C. I have 1/3 x squared. So I know 1/3 has to be wider than our parent graph, so it needs to be my widest graph. So I'm going to say that has to be the red equation. 3 is a larger than 1, so that has to be my narrower graph, so that will be blue. And then my parent graph is my one that needs to be in the middle. And also I could check the parent graph by doing those values that we have memorized: 1, 1, 2, 4, negative 2, 4, etc. So that would be the black graph. Here's another way of looking at it. So if our equation is given to you in factored form, that's when you have it, the zeros factored out here, we can do our P and the Q going to be our x-intercepts. So x-intercepts are equal to P or Q, or setting each parentheses equal to 0 and solving for the P or the Q. The axis of symmetry is halfway between those two x-intercepts. So that means we're going to add P plus Q and then divide by 2 to get our axis of symmetry. Our vertex has the same x value of our axis of symmetry. Then we're going to take that value, plug it into our equation to get our y value of the vertex. 2 and row 3 are written in what we call vertex form. Both includes a perfect square, x minus h quantity squared. So you often use complete the square to do this. The difference in between the two is one has a plus k and the other one doesn't. In this first one, without the plus k, our vertex is on the x-axis. So it touches the x-axis at h. That means our x-axis symmetry is x equals h, and our vertex is h comma 0. So very easy to find. Next one, we have our vertex is at h comma k, and our axis symmetry is x equals h. X equals h is the axis symmetry. Our last one here is an example written in standard form. With standard form, our y-intercept is the easiest to find. It's just the number by itself that has a variable in it. Our axis symmetry is x equals opposite of b over 2a. Our vertex is opposite of b over 2a. And then the y value is the function value evaluated at opposite of b over 2a. Another way you can do it is it could be c minus b squared minus 4ac. I always find that hard to memorize, so you don't have to memorize that formula if you don't want to. You can just memorize, find the x value of the vertex, plug it into your equation, and get your y value. Our x-intercepts exist if our discriminant is greater than or equal to 0. And to find our x-intercepts, usually we're going to use something called the quadratic formula that we practiced in the last section. We're going to use our x-intercepts and our vertex to sketch the graph. So first we're going to find our x-intercepts. So in this example, this is the intercept form. So p is equal to negative 3, since I have x plus 3. Opposite of that would be negative 3. And then our y-intercept is, and the other one is negative 1. So our x-intercepts, remember, always write our intercepts as a point. So it's going to be negative 3, 0 and negative 1, 0. So make sure you write it as a point. Our y-intercept is found when we set x equal to 0. So I just go to my equation, replace every x with 0, simplify down, and I find my x-intercept to be the point 0, negative 6. Finally, I want you to add this step. I want you to find the vertex. So it's halfway between our two x-intercepts. So p is negative 3 and q is 1. So I get negative 3 plus 1 divided by 2, which gives us a negative 1. Then I take f of 1 and replace every x into my original equation with negative 1. Simplify down. And I end up with negative 8. So therefore, my vertex is the point negative 1, negative 8. Now we're going to take this information, we're going to sketch the graph. So I'm just going to plot my x-intercepts, my y-intercept, my vertex, and then connect the dots with a smooth U-shaped curve. Notice that A is 2, which is positive, so I should be concave up or opening up. Let's see if that's what happens. To help me out, notice I added an extra point using my axis of symmetry, which is the same distance from my axis of symmetry line. Also, always remember to label your vertex. Okay, let's look at our next example. Find our x-intercepts by setting the x minus 1 equal to 0 and x minus 2 equal to 0, or get our p and q. So our x-intercepts are 1, 0 and 2, 0. Y-intercepts, replace x with 0. Simplify it down, we end up our y-intercept is the point 0, negative 4. Finally, I'm going to find the vertex. So remember, vertex is p plus q divided by 2. And then the function, then plug that into our function. So our vertex is 3/2. Our x value of vertex is 3/2. Plugging that into my equation. My y value of the vertex is 2. So now I have my intercepts and my vertex. I'm ready to sketch my graph. Also, I noticed that my a term here is negative 2, which is negative, so my function will be concave down, or u facing down. So I'm going to change the scale on this one. So I'm only going to change the x-axis. So notice how I labeled it. Then I'm going to plot my points on my graph. And then again, to get the axis, I'm going to use axis symmetry to get my corresponding part. So I have 5 points here to graph. And then I'm going to sketch my U-shape. Finally, labeling my vertex. Our last example, we're going to find our x-intercepts the same way. So my p here is going to be a negative 2. And I noticed that I do not have a y or anything like this, so that I know this is an example where my vertex is my x-intercept. My y-intercept, I plug in, replace x with 0, and I get a y-intercept of 2. So my x-intercept was negative 2, 0, y-intercept was 0, 2, and I know my vertex is the same as my x-intercept in this form. So I don't have to do any work on that one. And then we're going to sketch our points. This is very, very important that you have to use your symmetry. So first, got to figure out open up or down. Well, it's positive, A is positive, so I'm opening up. So I'm going to use that axis of symmetry to find my third dot. I have to show that. I have to work that out because a minimum to graph a quadratic is 3 points. 5 points is preferred. Then label your vertex. Our next example, we're going to use vertex, axis symmetry, and y-intercepts to sketch the graph. So let's find the vertex of this equation. So I know it's hk, so it's negative 1, 4. Axis symmetry is just x equals negative 1, x equals h. Y-intercept, that's when x is 0. So that occurs when x equals 0. So I'm going to go to my equation, replace x with 0. Simplify this down, I end up with a y-intercept of 2. So I'd write the point 0, 2. And then A is negative, so that tells me it's concave down. The graph opens down. Okay, I'm going to do a really quick sketch this time of this. So I'm going to plot my vertex in some key symmetry points. So I'm going to start with my y-intercept, axis of symmetry. So here's my axis of symmetry, x equals -1. My vertex, my y-intercept, using that line of symmetry to get my third point, and then sketching the curve. Label my graph with my vertex, of course. Equation. Let's look at an example of an equation written in standard form. When it's written in standard form, it's very helpful that the first thing that you do is identify what your A, your B, and your C term is, just like we did when we solved quadratic equations using the quadratic formula. Now, part A asks us to find the axis of symmetry. You need to recall that the axis of symmetry is found by the following equation: x is equal to opposite B divided by 2a. So that will be, in this case, -6 divided by 2 times 2. We're going to simplify this down, and we get x is equal to -3/2. Make sure you write the axis of symmetry as an equation. Part B, find the coordinates of the vertex. So recall the vertex is found by assigning the x-coordinate of the axis of symmetry is your x-coordinate, and then plugging that into your original equation to find the y-coordinate of the vertex. I'm going to simplify this down, and I end up with -15/2. So therefore, I have the conclusion my vertex is the point -3/2, -15/2. On the axis-intercepts, so that means the x-intercepts and the y-intercepts. So let's start by finding our x-intercepts. Recall our x-intercepts are found by using quadratic formula, setting the equation equal to 0 and factoring. So you can solve this any way that we learned of factoring. I'm going to use the quadratic formula in this example, substituting my a, b, and c in and simplifying it down. Make sure you remember to rationalize, simplify the radical, factor out your GCF from the top, and I end up with x is equal to -3 plus or minus the square root of 15. Step D, we're going to actually find the decimal value of this. So I'm going to use my calculator, plug in -3 plus or minus square root of 15, and I get x is approximately -3.44, or x is approximately 0.436. So again, you can write that as your x-intercepts. Make sure you include the exact answer as well as the approximates. Now to find your y-intercepts, this is when your x equals 0. So it's your c term, so that's easy to find. My y-intercept is 0, -3. I'm always listing all my answers together, and notice I list the exact x-intercepts and I listed the approximate x-intercepts. And then also identify if your graph should open up or open down. And finally, we're going to sketch the graph. I'm sketching the axis of symmetry. Remember, I sketch it as a dashed line, and I'm going to label that x equals my -3/2. Then I'm going to plot my vertex, label it, my x-intercepts and my y-intercepts. So here's my two x-intercepts. And then finally my y-intercept. Now I'm going to use my axis of symmetry to do my fifth point and then draw the U-shaped graph. It's useful to rewrite standard form equations into vertex form equations by completing the square. So that's what we're going to do in this example. Remember, step 1 to complete the square is to group your x terms together, and then I need to find some number I need to add to the x terms but subtract from the constant so that I have a perfect square. Since my b is positive, I'm going to have a +2. 2 squared is 4. I added 4, so I'm going to subtract 4 from the problem. Now I have the equation written in vertex form. Find the vertex. Remember, vertex is h, k. So in this case, my vertex would be equal to a -2, -1. Now identify my axis of symmetry, which is x equals -2. My y-intercepts, I replace x with 0, so y-intercepts curve when x is 0. And end up that my y-intercept is 0, 3. This is enough information to sketch the graph. So let's start by plotting the vertex. Oh, I forgot to look if it opens up or down. So A is 1, which is greater than 0, so this graph opens up, so concave up. So I'm going to label my vertex. Next, we're going to sketch in the axis of symmetry, labeling the axis of symmetry. Plot my y-intercept, use my symmetry to find the corresponding spot on the other side of the axis of symmetry at the same height as my y-intercept. Now I have 3 points, so I can sketch the curve. Remember, it's okay to use only 3 points to sketch a graph as long as one of those points is the vertex. Okay, for our last example here, we're going to convert this standard form into vertex form. So we're going to do the same thing. We're going to do complete the square. The only difference with this one is now I have an a that's not 1. So I need to factor out that 3 from my x terms before I set up my blanks. So I'm going to add some term in the side. I need to subtract some number so that I'm going to have a perfect square here on the bottom. So I'm going to take negative 4/2 divide by 2 to get my bottom blank. So that's going to be x minus 2/3. I'm going to take negative 2/3 and square it to get my top blank. And I'm going to times this by the a, so times by 3, to get the blank over here. Combining 1 and negative 4/3, I get negative 1/3. So now I've done part A. I've rewritten this in vertex form. I know my vertex is 3/2 comma negative 1/3. My y-intercept by replacing x with 0 and simplifying the equation down. So I have a y-intercept of 0, 1. So let me get all this information down so we can see it. I can clean up some room. So I got my equation in vertex form. I've identified the vertex, identified my axis of symmetry, which is x equals 2/3, and identified my y-intercept, which is 0, 1. And looking at A is 3, which is positive. I know my graph opens up or concave up. Okay, let's sketch the graph. Notice I've counted by thirds. So I'm going to plot my vertex and label it. Plot my axis of symmetry, label it. Graph my y-intercept. Use my axis of symmetry to find a point that's symmetric to the y-intercept, and draw my curve. I have completed this graph without the use of technology. Our calculators, and to check our work using our calculator. So go to your y equals, substitute into the equation into the y equals as the original equation given. Set up your window. I know I don't have a lot here, so I'm going to just do negative 3 to 3. And then graph. Text, do second trace to calculate. Minimum, which is 3. Left bound, we're going to move the cursor to the left of the minimum value or the vertex. Push enter, move the cursor to the right of the vertex. Push enter, enter one more time, and there's our minimum value. Since it's concave up, we have a minimal. If this graph had been concave down, I would have had a maximum. So let's compare this answer that we just got from the calculator with the answer we got algebraically. So I know 0.6666 is about 2/3, and I know negative 0.323 is about 1/3. So that means here the calculator is saying my vertex is 2/3, negative 1/3, which is true. Now let's check our y-intercept. It looks like it's 1, but let's make sure. So I just hit trace 0 and enter, and that gives me my y-intercept. So yes, it is the point 0, 1. So yes, let's really verify my answer using technology. You need to know is something called positively defined quadratics and negatively defined quadratics. Okay, a positively defined quadratic is a quadratic graph that is always positive or always above the x-axis. If a quadratic is a positively defined quadratic, what you need to do is you need to look at the a, and if the a is positive, it means it's concave up, and your determinant is negative, means there's no real solutions. And then you have a positively defined quadratic. Negatively defined quadratic, on the other hand, the a is negative, which means it's facing down, and your determinant is also negative, means there's no real solutions. So use the determinant to determine the relationship between the graph of each function on the x-axis. So first I'm going to look at my determinant. So I'm identifying my a, b, and c. Solve for my determinant by substituting in my values. Here I get a determinant which is equal to negative 7. Since my determinant is negative 7, which is less than 0, we know this has no real solutions, so the graph does not intersect or cross the x-axis. So there's a possibility. So I could have positively defined or negatively defined. To determine which one it is, I look at my a. So my a is greater than 0, it's concave up, and so it is positively defined quadratic. So how would I write my answer? Okay, you could say something like this. Since the determinant is less than 0 and a is greater than 0, the graph is a positively defined quadratic. In our second example, a is negative 2, b is 5, c is 1. I'm going to first find my determinant, and I find my determinant is equal to 33. So since my determinant is not negative, I know I do not have a positively or negatively determined quadratic. But I know my graph is concave down. So how can I write this answer? Since my determinant is 33, the graph crosses the x-axis twice. And since a is a -2, the graph is concave down. And that's the one way that you can describe it. I encourage you to do a quick sketch. That always helps your discussion answer.